Welcome to AI Talks, a place to come and listen to IBM customers, partners, and colleagues talk about the digital organization and how AI, hybrid cloud, and enterprise software is critical to success. Let me hand over to my colleagues to get us started. Hi, my name is Paul Russell from IBM, and I'm really pleased to be joined today by Lucy Horner from London Array Limited and Richard Donaldson from BPD Zenith, one of our business partners. So we're here on AI Talks to discuss Lucy's world at London Array, the world of offshore wind provision, and really focus on the operational maintenance side of how Lucy and her organization keep the lights on in the fascinating area that all of us benefit from in terms of how we live our lives, and really how Lucy and her colleagues are using digital platforms like IBM Maximo to transform what she does. So it's going to be a great podcast today. And so Lucy, welcome to AI Talks. And if I may, kick it off by just asking you to tell the listeners a little bit about London Array and the work you do for them.
Sure. Well, thank you so much for having me. I am a maintenance strategy engineer and I work as part of the asset integrity management team at London Array. So effectively, we help plan maintenance works, we deliver maintenance strategies, anything that is geared towards effective asset management and operational management too. We have 175 offshore wind turbines in the Thames Estuary, and they're about 20 kilometres from the shore. We work out of the Ramsgate port. And yes, we produce a lot of electricity for the national grid.
Did I read somewhere that it was or still is one of the largest offshore wind provision?
We did have the accolade of the largest offshore wind farm in the world for a number of years, but we have subsequently been overtaken in terms of power generation capacity, but we are still one of the largest in terms of the number of turbines we have. So that obviously has its own unique operational issues just because of our vastness of having 175 machines to keep upright and keep working and generating.
The complexity of a turbine in terms of assets. It could be that, when I think about an aircraft, there's thousands and thousands of individual parts or assets and how they work as one single unit. Is there a similar kind of way you describe a turbine?
Yes, absolutely. And you could go into a number of different levels of the hierarchy. There must be thousands of components within each machine. And we may talk about an asset as a gearbox, for example, or a blade or a cable, but certainly there will be subcomponents to those as well. When we talk about asset management, we tend to think of the larger components. Effectively, if we would exchange it, that to me is an asset, or we may also repair an asset like a gearbox. Sometimes it depends how cost effective the repair might be.
There must have been a life before and a life after in terms of digital transformation that everybody talks about. And some industries are way further down the line than others. And I suspect in your world, you have a good before and after story.
Yeah, absolutely. And I mean, it's still an ongoing process. We're still learning and we're still trying to digitize, but we've certainly come a long way from using spreadsheets and paper-based systems, especially for work management and collecting information from the work that we do, such as inspections. Historically, that would have been many spreadsheets. And since developing and using tools such as Maximo and some other in-house software, we've been able to import that data into a system where we can actually see it and slice and dice and compare with other data. So yeah, we've come a long way from using just spreadsheets. It just helps us plan better now as well. Having one system, which is the London Array focus, is to have one business intelligence system, which is made up of several different types of software, including Maximo. The idea is that we have all of our data in one place so that we can easily look at everything in context. And that helps us plan, for example, some of the difficult logistics we have of getting people offshore to the right turbine, making sure they do the right work. The actual facilitating technicians to a turbine can itself be very difficult because we have varying sea depths in the field. We have lots of different crew transfer vessels, but they have different capacities, different abilities in certain weather types, weather conditions. You have to know which direction the current's going. We have to know how much water depth is at the turbine. We have some installed in very deep locations, some installed in very shallow locations. So you'll need a different vessel to get to that turbine. So bringing all this data together, such as weather, tide restrictions, wind direction, vessel capacity. That's just one part of the puzzle. That's just getting people to the turbine offshore. On top of that, we have with the work management side of things. So we use Maximo to help us validate that we have the right work documentation in place before we send anybody offshore, that we know exactly what work they should be doing, that they are capturing the correct information when they get there. If we can pull that back into the same system, we have all the information we need to be able to make a decision for the next inspection, for example.
There's one word that I will probably come back to, and this is obsolescence, because the way you've started to describe even just the journey. I mean, in my naivety, thinking about how to get out to a turbine, even just some of those things you mentioned about sea depth and, getting the crews and because of the conditions and the weather and all these factors moving into the level of complexity just must grow and grow. And I suppose my question then would be, there's got to be a bit of digital intelligence, but also pure experience of people.
Absolutely, and that's the sort, we can never replace human experience. We are reliant on having experienced vessel skippers telling us how to navigate a vessel through particular wind conditions. Although more recently, we have also been trying to support that experience with data as well. So there are also some trackers on some of our vessels which monitor, for example, a route within the field, because there are a couple of different options in terms of which route you take to get to a particular turbine in the field. And I must say this field is vast. It's about the same size as central London, the whole of London Array. So you can have very different weather conditions at one side of the field to the other. So yes, we are reliant on experience. We're also trying to now back that up with data. So sensor data will map the route, for example, and based on all the other data that we get, like water depth, current direction, wind speed, wave height, what we're trying to do is build some trends so that in the future we might be able to suggest a suitable route to a particular turbine, which is supposed to be designed to support the experience of the person actually maneuvering the vessel rather than replace them.
So lots of big data challenges, I suspect, but also kind of prediction maybe of what could happen or what is the best route or what is the best option to augment the human being, which, leads into things like role of artificial intelligence maybe in the future.
Absolutely. I mean, if we can get to a point where a system could say, perhaps you shouldn't take this route because historically a few people have reported seasickness in these particular weather conditions, that might help us prevent somebody becoming seasick, for example. That's the sort of thing that we'd like to get to, sort of a suggested route based on conditions, based on previous learning, the goal being delivering technicians to a turbine safely without making them ill.
Yeah, I mean, I guess seasickness, it's never done well for me in the past, so I tend to fly now. Well, I used to fly.
Yeah, I mean, some people do fly their technicians to vessels stationed offshore usually, or platforms to do some turbine maintenance, but we're not quite far enough out to sea to justify a helicopter flight, for example. We use crew transfer vessels because it's about an hour on the vessel.
Again, I can imagine health and safety is paramount for London Array, people first. And therefore, how do you use any tools or platforms to improve that area of responsibility that you have for your people?
Absolutely, and we should never underestimate the conditions offshore. We are driven to make it as safe as possible, but absolutely safety comes first. And our ultimate goal is to get people out to work and home again in the same condition that they started the day. So we use tools to keep people safe by, for example, validating that they have the right competency and experience to do the job that we would like them to do. We use Maximo job plans as a reference for that, actually. So we have a particular job plan record, and attached to that would be approved documentation. We would stipulate some fields in that job plan, for example, where the work's taking place, what type of work it might be, and a work coordination group, such as the asset integrity management team or an operations team. And then we use that reference and we copy some of that information using an automation script onto a work order. And then that information is pushed into another London Array in-house system, which will take this data out of the work order, cross-reference it with the competencies required for this particular work type, and then validate that the people scheduled to undertake this work, that they have the right certificates to show that they are qualified, for example. So that's one of the ways that we keep people safe, is by making sure that they are very comfortable and knowing what they're supposed to be doing. We've got all the right documentation in place, and they're not going to put themselves in danger. And also to show through the documentation that we've done everything we can to mitigate risks to their safety.
Leading on from that, then, demonstrating this compliance, you must be incredibly regulated as an industry for lots of reasons. Can you talk a little bit about how, again, some of the digital tools are helping you, achieve that regulatory compliance?
A big part of our inspection and maintenance campaigns, every year we have to inspect our safety and lifting equipment. So that will include the equipment that a technician might clip onto his harness in order to climb up the turbine, in order to access it to do some maintenance. So again, it's about delivering people safely to their place of work. The equipment that they might use to clip onto would protect them if they were ever to slip on the ladder mid-climb, so it will stop them falling in the sea. That's the idea. And there are government statutory regulations that mean we have to inspect this equipment at least once a year to make sure that it is fit for purpose and safe to use. So there is an expiry date on that inspection of, say, 12 months. If we were to miss that 12-month deadline, then that equipment, even if its actual condition is fine, we were legally not allowed to use it because we haven't checked that it's okay and safe. So we would not risk using it until it has been inspected properly and certified as safe to use. And actually, speaking earlier about a before time, we sometimes missed these inspections because we didn't have one single source of truth about what the expiry date might have been. You can double check by checking the sticker, which is physically stuck onto the equipment, but obviously you can't check that unless you're there, and you would possibly even have to use the equipment to check it. So unless you've got a good record of what those expiry dates are, you can't guarantee that you'll get there in time. And before, there were some issues with inspecting this seemingly tiny, unimportant piece of equipment in comparison to the rest of all of the assets in the machine. For example, this fall arrest unit isn't particularly production critical, but if a gearbox needed inspecting, then you would absolutely need to use this fall arrest equipment in order to get up to the gearbox safely. So now we have a very good work management system using Maximo, where we record all of our inspection dates and therefore the 12-month later expiry date, and that helps us manage work and plan effectively. We don't miss any deadlines. We make sure that this equipment is safe to use and fit for purpose. Of course, if we inspect it and it's not okay, then we would take some remedial action too. But that's a very small, seemingly small piece of equipment can have a huge knock-on effect to being able to access those turbines safely.
Have you been out to one of the turbines?
Yes, I have. I've been very fortunate to have done all of my safety training, and I've been offshore to several turbines, possibly 10 times in the last 7 years. So I'm not much of a regular visitor, but I try and get offshore 2 or 3 times a year. It makes my job much easier if I have an actual reference,
because you can actually you can visualize and the assets in its real context.
Absolutely, yes.
And I guess you're also not seasick.
I've been close. Even though I'm usually a fair weather sailor, but not always lucky. But yeah, no, it's really good for my familiarity and experience. And a lot of my job is writing work procedures. And I can't effectively write a work procedure to an experienced technician if I haven't backed those words up with some actual experience of the asset itself or the location. It's very different on paper to actually being there.
I hoped you did say that you had been out, so thank you. That's really good.
Yeah.
So Lucy, this is great. And I'm just thinking about the future. At IBM, we are pretty obsessed about talking about digital twins. And, in certain industries like aerospace, it's very valid that a digital twin is the right language. But I just wonder, because your environment is so different in terms of the just literally the environments, turbines out in the sea and all the challenges you've talked about. Is digital twin, something you even talk about? And if it is, then in what context are you doing that? Or do you not even think about digital twins?
I think we probably talk about the same thing in slightly different language. So something we would use quite a lot of is modeling. So we use models to help us predict weather forecasts, weather conditions for each individual wind turbine. And we are also in the process of modeling, for example, fatigue life of a wind turbine foundation. The foundations in particular are pretty inaccessible because of their position. I mean, half of it is in the subsea underground, the other half is underwater most of the time. They are less practical to inspect than, for example, the turbine above sea, which is accessible by ladders and lifts. So there is value in modeling the behavior of that civil structure in the seabed. If we can collect information about the conditions around it and perhaps take a snapshot, and in the future, hopefully even retrospectively install some sensors like strain gauges, for example, so that we can start to understand the behavior of the foundation and its position offshore without having to physically be there.
What is the lifetime then of a turbine?
Generally speaking, about 25 years is the design life. What we would absolutely hope to be able to do is extend that life beyond 25 years. But we will not be able to do that unless we understand the actual life of the asset as it is now. So we have to go through a process of validating those design assumptions effectively. And in the most cost-effective means that we can do that. I mean, visiting annually isn't cost-effective. So we're now looking at things like strain gauge data, sensor information, creating a model based on wave data, seabed movement, because the sand in the seabed moves around all the time. That can affect how the structure vibrates, for example. So we need to collect all of this information and put it into a model, and then we can start saying, well, what if this happens? What if we get I don't know, once in a lifetime event? How will that affect the life of our turbine? What if we just continue business as usual? What if nothing changes? How long will we get? Were our design assumptions correct? Will we be able to achieve 25 years? Obviously, the ambition is that we achieve many more and make this the most cost-effective investment as we can.
The obsolescence in a lot of road networks is extreme. Many motorways and bridges are way past their sell-by date, and there's a huge shift now to use drones for inspection. I just wondered, is that viable in your world to use drones to do inspections?
Yes, absolutely. That's something that we have more recently, maybe the last 2 or 3 years, actually implemented very successfully with our blade inspections. As you can imagine, a blade, there are 3 per turbine, and physically inspecting them can be a very huge, awkward challenge. They're very large. One of the ways you could do it, for example, would be to hire a very expensive jack-up vessel, which is a platform in the sea with legs that support you whilst you jack up and have a look. Obscenely expensive and very cost ineffective. You could also ask a technician to secure himself using ropes and physically inspect the blades that way. Either we have to spend a lot of money or put somebody at risk of falling from height. So what we've most recently been able to do is engage with a company who would fly a drone around the whole scale of the blade. They take images every few seconds or so, and then they have some software which stitches all the images together to effectively create a 3D image of the blade. And also you can use those images to identify any defects, and they categorize those defects in terms of severity, and that helps us monitor the condition of the blades without having to send anybody up close to them. So yes, it's been very successful.
Okay, so Richard, I just want to bring you in now because as you're our partner and you've worked with Lucy and London Array, I'm just wondering 2021 big bets for you, either with London Array or, generally around how you're going to do more great projects using Maximo. Just, a bit of a stargazer in terms of this year.
No, thanks, Paul. Yeah, so certainly we were working with London Array for many, many years now. And what we've seen with them and with a number of our other clients as well across different industries is really the better use of sensor data. I think a lot of companies now are looking at the difficulties that COVID's causing currently, and that's probably not going to go away that soon, and certainly is making people rethink about how they can be more efficient and better at what they're doing and collecting data more efficiently and easier. And I think sensor data and pulling data from things like IoT devices and things like that is a great way of doing that. So what we're seeing now and what we can expect to see a lot more going forward over the next year is actually collecting data through sensors a lot more and actually making better sense of that data and to understand what the asset's doing, how that asset is performing, how it's what the health is like, and really kind of using dashboard and systems like Love Your Asset to really understand and to get to the bottom of how well the asset's performing and when you're going to need to go out and maintain it and repair it before it breaks down. I think what that allows you to do then is be a lot more efficient over your maintenance, deploy your maintenance teams better and smarter, and make sure that things get repaired when they need to be rather than on a direct schedule, which is what probably a lot of companies have done previously.
Thank you, and look forward to doing more work with you, Richard, in 2021.
Definitely, yeah, certainly looking forward to it.
Lucy, I think we're done. I think you've given us a tremendous insight into your world. Certainly, I've learned a tremendous amount, and I hope everybody listens to this is going to capture the same experience as well. So thank you so much, Lucy, for your time.
Thank you so much for having me. It's been very enjoyable.
It's been our pleasure. Thank you. And Richard, again, great having you supporting us as our partner, and good luck for 2021. We do more work together.
Thanks very much. Look forward to it.
You've been listening to AiTalks podcast. I hope you've enjoyed it, and give us some feedback. Have a great day. Thank you.